Hi guys, our group is Group 3 and the topic of our group is Smart Agriculture. So firstly, I'll talk about the background of smart agriculture. Smart agriculture refers to the management of farms using modern information and communication technologies to improve product quality and quantity, while minimizing the need for labor-intensive human labor. IoT devices are implemented to enhance the farming process by repetitively collecting and analyzing data. And then as a result, it allows farmers to monitor their field conditions from anywhere and perform immediate actions to fix any issue that arises from their field quickly and efficiently. So now I will talk about the history of smart farming. In the year 1990, John Deere started to use GPS in precision agriculture by creating GPS receivers that enable features like yield mapping. It utilized sensors and mapping tools to analyze soil conditions, temperature, moisture, and other environmental factors in order to estimate the crop output in various fields. As a result, farmers are able to use this data to allocate resources in the future and identify the best seed types and crop management techniques. Furthermore, I'll discuss about the future trend of smart farming. The FAO estimates that agricultural production will need to rise by 70% in order to feed the large population. Smart farms use technology like the IoT, AI, and robotics to operate the farm efficiently and intelligently. The smart agriculture market was estimated to be worth 13.8 billion in 2020, and it is anticipated that by 34 billion in 2026. In addition, I will discuss about the problem statement of our project. So the impact of climate change on agriculture is causing an increasing concern, and the need for a solution to help farmers to cope with this challenge is more urgent than ever. Next, the second problem statement is the overuse of some agricultural inputs, specifically chemical inputs, can cause the depletion of natural resources and environmental degradation, which in turn leads to the emission of greenhouse gases. Next, the objective of our project is to develop a solution that can utilize the existing cloud service provider to assist farmers in optimizing moisture and nutrient level of crop. So in this project, we will make use of the AWS as a platform to develop the project and achieve the objective. So lastly, I'll talk about the study and comparison of different IoT platforms such as AWS IoT, Microsoft Azure IoT, and IBM Watson IoT. So the strengths of AWS IoT is it offers robust device management and data processing capabilities, making it ideal for companies that need to manage a large number of IoT devices. While the drawbacks of AWS IoT is the platform can be challenging to set up and configure, especially for new users. Next, I'll talk about the strengths and drawbacks of Microsoft Azure. So the strengths of Microsoft Azure is it provides excellent integration with other Microsoft services, making it ideal for companies that are already using Microsoft technology. So next, the drawbacks of IoT Azure is it can be expensive, particularly for larger deployments. Besides, some users have reported issues with connectivity and stability of the platform. So lastly, the IBM Watson IoT is good at it focuses on cognitive computing and AI capabilities, making it a powerful platform for companies that are looking to gain insights from their IoT data. On the other hand, the drawbacks of IBM Watson is the integration with other IBM services can be complex and time-consuming. That's all from me. Thank you.
Hello, my name is Goyong Chin and my student ID is 2004936, and today I will be presenting the architecture diagram for our group. So we can see that there are actually sensors that are being deployed at the first part here, where it is used to collect data for the moisture level and the soil nutrient level. The soil nutrient can include nitrogen, phosphorus, potassium, and also magnesium. And these sensors itself will be used to collect this type of data. And then for the IoT device, it actually acts as the water sprinkler and also the pesticide sprayer. And then firstly, so in order for the sensors and also the IoT devices to connect to the cloud, we will connect it to a router where it will be able to get internet connectivity and it will get access to the cloud. And then inside this router, the data from the sensors will be sent into the AWS IoT core, which is located in the cloud by using the MQTT protocol. And then when the AWS IoT core receives data from the gateway, it actually also receives command from the AWS Lambda in order to perform some actions by using the IoT devices, such the water sprinkler and also the specific. So next, the raw data from the sensors will be sent to the AWS Lambda and also to undergo data processing and also transformation before it is passed to the Amazon DynamoDB. So in the Lambda, there is actually three main functions. The first function will be the rule-based trigger for the SNS, and then it will be used to evaluate data and also raise alarm and trigger action if necessary. So in order to raise the alarm, the Amazon SNS is set to notify the users via email, SMS, or push notification if any of the parameter for the soil nutrients or the moisture level are beyond acceptable threshold. And then for the second functions, it is used to act as a trigger where the Amazon API gateway will generate a URL and then user can click on the URL to trigger the Lambda functions where it will be able to act as an on or off switch for the sensors to send messages. And then lastly, the third functions, it is used for the pre-processing and also the data transformation in order to pass the data into the Amazon DynamoDB. And then inside the Amazon DynamoDB, the data will be further transformed into the .csv format and it will be stored inside the S3 for further process. And then inside the Amazon S3, it will use the data to provide data for the visualization, also the machine learning training. Then after that, inside the Amazon SageMaker, it will use the data provided by the Amazon S3 in order to train its machine learning model and make prediction on the future health data of the crops. And then lastly, the Amazon QuickSight will also use the data from the Amazon S3 in order to provide the visualization purpose. So it will act as a dashboard that display the data trend in near real time by using the data. So the end user can be farmer or user that use the web application to observe the moisture level and also the soil nutrient level trend and take necessary actions to fix any possible problem. So that's all from me. Thank you.
Okay, my name is Liu Weizen, and now I'm gonna demo our architecture diagram. So the first thing, in order to receive the data from sensor, we need to configure our IoT core first. So from here, you can see there's a thing here. Everything's represent a IoT sensor. So we can click on the things and see. The most important thing for this is actually the certificate ID. So we use this certificate ID to let the AWS cloud to identify our sensor. Therefore, the sensor can publish it to a topic, then subscribed by the cloud. So in order for the sensor data to be direct to others AWS service, like we can see over here, AWS Lambda, we need to use the AWS IoT rules. We can see the rules here. We have 3 rules activate currently. So let's click one for the example. We can see currently this rules is actually subscribing this topic. Actually, this topic is a topic where one of the sensor that will publish the sensor data to, and we select everything from it to read it. And also the action is we will send the message read from the sensor to Lambda function. So we can see over here. So the other thing I want to point out is the SNS. So the SNS over here is to allow the user to receive some message from AWS cloud. So the first thing we need to create a topic. So you can see the detail of it. So this SNS topic is to actually send an email to this endpoint. So this is the email of the endpoint, the target. So the next thing is the AWS Lambda. So just now we already direct the message from the sensor to AWS Lambda. So we can see over here, the AWS Lambda, I'm currently using these two functions. One is to check the data, incoming data from the sensor to check whether certain threshold is breached or not. So if the threshold are breached, an email notification will be received by user. You can see the code over here. The important thing is actually the topic on, which is the topic over here. So the Lambda function know which topic they're gonna be send a notification to. So if the certain threshold already exceed, right, the user will receive an email from it. So the AWS notification, the alarm, right, will look something like this. This is what we want to send from the AWS Lambda function. We can see over here. So this thing. Another function is actually pre-processing the sensor data, the incoming sensor data. So the idea here is because the incoming data is in a JSON object format, so we need to store this data into DynamoDB, but we don't want it represent as a single item. We want every single item inside the object to represent as a column. So this function over here, they will pre-process the data and store it inside the DynamoDB. So over the DynamoDB over here, you can click on the table, we can see. This is how the data should look like. Instead of a single object, we separate the incoming sensor data and process it into every column like here. So we can easily visualize it on a dashboard. So at the same time, when we store the data inside the DynamoDB, we also store the same data, exact same data in S3 over here. So the data will be stored inside a CSV format. This is the reason we store inside a CSV format is to make visualization easier from using QuickSight, and also this CSV format will be used for in SageMaker for doing machine learning. So this is everything for my part in the demo.
Hello, Miss. My name is Yong Chong Wei. Now I would like to proceed the rest of the service demonstration. So just now, Liu Weizhen already demonstrate until the Amazon S3. So I would like to proceed to Amazon QuickSight. So in our project, we import the data from S3 to Amazon QuickSight to do the data visualization. So it is the result that we done in QuickSight to do the data visualization. And we do it in a line graph to present the data, to visualize the data. And the x-axis is represent the timestamp, and the y-axis is the parameter of data, such as temperature, potassium, and magnesium. So after the Amazon QuickSight, let's proceed to Amazon SageMaker. So in our project, we use Amazon SageMaker to do machine learning that we want to predict the health level. So in Amazon SageMaker, we decide to use SageMaker Canvas, that is no-code machine learning. So first of all, we require to import a data set from S3. So in data source, we just choose Amazon S3 and select the data set and import the data. So the data is already import previously, so I don't want to import again. And after imported the data, so we can go to My Module and create a new module and provide a name to the module, for example, test, and click predictive analysis and click create. So after we create a module, so we choose the data set for training later. So we choose the imported data just now and select the data set. So after select the data set, in this section, we need to choose the target column that we want to predict. For example, we want to predict the health level, so we choose the health level, and we just click preview and start preview to start the training. So the training I already do previously, so I don't want to do again. So after the training done, it will display the accuracy of the module and is able to start to do the prediction. So in prediction is user able to do in batch prediction or single prediction. So in single prediction, user able to insert the value for each of the column, such as potassium, magnesium, calcium, and others. So after we insert the new value, just click update. It will start to predict the result. So the predicted result is 2 for the health level. So if user want to download the result, user able to click the download prediction and choose whether they want to download in CSV or image format. So in batch prediction, user required to select a data set, such as I choose this data and just click generate prediction. So just read the status to ready. So after the status is ready, so we able to preview the result. So all the uh, all the result is predicted. So if user want to download the result, user can just click the download CSV to download the result. So that's all for the Amazon SysMaker. So after that, I would like to proceed to Amazon API Gateway. So in Amazon API Gateway, we create a URL to create a URL to trigger AWS Lambda, and the AWS Lambda will trigger the sensor device on or off. So now we like to demo about the API Gateway. So now assume the sensor is off now, and we just click the URL, and the sensor will start to will on and start to will providing the data to and the IoT will start to receiving the data. So if we just click again, and the device will off and the data will stop receiving. So that's all for our demonstration. Thank you.